more introduction, who we are, what our focus is, so you just get a flavor for our capacity and capabilities, as well as then I'll turn it over to Bala to go through the technology evolution of what's happening on the manufacturing space, and then give you a little bit of understanding of why and what we believe this is a great topic to go through for all of you on the phone. And then we're going to pass it to Swapnil, who's going to talk through our use cases and demonstrate the actual solution to you. So on the next page, it's really just trying to give us three, just a quick introduction. I'll pass it to my colleagues. Fred Bellio, managing partner at Driven 4, been in industry over 30 years, lots of OEM industries, be it Whirlpool, Brunswick, Mercury Marine, Ashley Furniture. We started our company about 4 years ago. We want to focus on the manufacturing PLM space, and we do industrial IoT, and I'll pass it over to Bala.
Thank you, Fred. Good morning, everyone. My name is Bala Shetty, and I'm also one of the managing partners here at Driven 4. I primarily manage all PLM and industrial IoT side of the business operations at Driven 4. I have extensive background and experience within manufacturing and product development domain. Swapnil?
Thank you, Bala. Hello, everyone. My name is Swapnil Gavande. I got 16 plus years of experience in IT and especially into PLM and IoT. I started as a developer and played a solution architect role with working with Whirlpool, and then managed a couple of programs, the PLM program, while working with some of the IT companies like Capgemini recently. I'm responsible for the offshore team at Driven 4 here in India. And we have got a very amazing team here and exciting projects and very good capabilities. Looking forward to having a wonderful session today. Thank you.
Thanks, guys. Thanks, Swapnil. Just a quick overview, as we discussed, right? We are technology and industry leaders coming with you of many years of OEM, I'll call it experience. Our basis is really, being in your shoes for the past 25, 30 years, making those tough decisions, trying to sell these kind of solution sets to your colleagues and to your senior management. So we focus on three main things: PLM, IoT in terms of connected IoT on the shop floor, as well as our connected product. And we actually wrap around that our cybersecurity practice, which is really focused on, how do we ensure we have a hardened manufacturing environment and a good environment from a solution set when we deliver connected products through apps, through web pages, and connecting that through different platforms like cloud platforms like Alexa and Google Home. What we believe is I'll call it our competitive advantage is our approach. When we do things, we really look at it from a holistic standpoint, from the company perspective. We always look at it from how do we scale and make sure that it's an environment and a solution set that will fit within your full architecture of an organization. So we don't really like to just do point solutions, because we know what happens with point solutions. You start and then they just kind of get, I'll call it, sidelined. We want to make sure that we provide you with that kind of experience, as well as the understanding from a solution set as we go forward. Here is just a pictorial of really what we try and classify as our digital transformation. Ours is really around, we focus on the product development aspect when it comes to innovation, design, validation of that design, into manufacturing, and then how do you want to deliver that to the marketplace, be a connected product. We believe the future of product development is a connected product and service. And with that end, we also provide software and mobility solutions when it comes to driving a visualization to the apps that you want to have for your colleagues, either on the shop floor or your end customers in the consumer space. But also we provide a holistic approach from an application managed service standpoint, where we can take your solution from start to end. So just a quick, brief introduction. I'm going to pass it to Bala to talk about the technology evolution.
Thank you, Fred. Our topic of conversation today is how do we create and deliver the digital work instructions to shop floor, especially how you can connect them with the PLM system. So I'm going to talk a little bit about the technology evolution, what Driven 4 team sees in the industry. If you look at the traditional PLM adoption within the industry, has been, CAD data management, the PDM side of the capabilities, along with the ECNs and ECOs. Now, what we are starting to see in the last 5 years, companies are taking their PLM embedment to a next level, especially in the areas of bill of materials management, or how they integrate and interact with functional areas like quality, manufacturing, and service. And also, one of the key things we see with the technology stack for PLM has been the progress made in the collaboration capabilities, whether it is internal or external parties getting involved. The overall solution framework has evolved very well in the last few years. So with respect to the digital work instructions, the reasoning and the typical approach, I see those three areas where it is making a compelling reasons for digital work instructions, right? The customers who are using Windchill today or any other PLM system, they have a complex solution for delivering the digital work instructions from other systems, and they're struggling to connect the information with their product development teams or the engineering. Number two, customers dealing with high rate of attrition within their factory level knowledge workers, and the challenge is how fast you can train and what tool sets and experience you can provide for an entry level operator in the shop floor. Then the third area here, I see customers who are looking at expanding their PLM capabilities, especially in the bill of materials management and engineering and manufacturing collaboration side of things, definitely are looking at digital work instructions. Now, from a technology evolution standpoint, we know the traditional manufacturing processes and business systems are disrupted and augmented with industrial IoT, right? It's the truth for the customers who are using a complex MES or any other MRP solutions. Definitely the industrial IoT has been augmenting and disrupting the way the approach and the solutions were delivered in the last few years in those four areas what you see on the screen. Moving to the next slide, especially on the digital manufacturing solutions, we see from a workforce productivity standpoint how the digital work instructions can improve the productivity and the quality of the overall operational excellence, while not avoiding the compromise within the safety and compliance side of the things. So digital work instructions are playing a key role in those areas. At the same time, with the solutions like ThingWorks, smart connected operations modules, you can enable the real-time monitoring, predictive, preventive, prescriptive side of the analytics from an end-state solutioning standpoint, along with monitoring the assets within your shop floor. The third area is more on the OpEx side of the things, and also how the solution can be scaled for futuristic real-time production performance planning and management side of the things, and also the other necessary training and validations for the knowledge worker to perform his day-to-day work. I'm going to spend a couple minutes to talk about the why and what. As Suk mentioned, please have your questions typed in the chat window for us to come back to those points as I go through this. The why and what here, again, as I pointed out, the operational performance improvement is a number one driver to enable the digital work instructions. For most customers, we see is part of their manufacturing transformation enablement or the roadmap. Definitely everyone wants to close the loop to the way their engineering and manufacturing teams collaborate, and also the end state vision towards real-time intelligence and predictive analytics, right, to improve the operations. If you look at the person working in the shop floor, he is under constant pressure to deliver the work with highest quality on a daily basis. And he deals with number of systems and information elements to keep himself up to date, and there is a major concern on that. And also the challenges for him to understand what got changed within 24 hours, what it means to his set of activities, and how that information is delivered to him. that whole process is not seamless today, right? So the digital work instructions can bring in the accurate, up-to-date information for the job order the operator is performing at the real time, right? Definitely this enables how we guide the knowledge worker in the shop floor, and also how the management side of the things can monitor the work performance and improvement opportunities in the same areas, right? So moving to another general thought from a driven core perspective is a lot of customers are talking about digital transformation, and there are activities happening in each of these business systems. But there is a whole lot of confusion in terms of what information gets managed where, and that conversation never ends. So what we see from our perspective with the customers we are engaged in the last few years, definitely the PLM is evolving, where all the product development and the upfront activities are managed, the production artifacts are, product artifacts are managed. People are starting to enable bill of materials management, bill of process, which includes the work instructions and process side of the documentation, and how the change configuration management is managed at the enterprise level, including at the product side. So those things definitely are all part of the PLM side of the equation. I'm not going to go through individual line items within each of these boxes, but as you can see, the traditionally today, the work instructions and process orchestrations are typically managed in an MES system or some custom solutions for the shop floor, but those things are slowly looked at moving those information back to PLM. As you can notice, even the technology companies have started to realize that yes, we need bill of material information in our transactional systems, ERP systems, but it's better off we manage those manufacturing bill of materials in the place where you manage individual parts and engineering information. So it is getting shifted to the PLM side of the things in a nice way. Then you have SCADA systems where all your sensors and automated guided vehicles, robotics, the sensor side of the things and the connectivity protocols are all managed. It's itself is our own technology stack. It provides a lot of insights and decision making for the end state data analytics side of the things for the customers. And the last area, the predictive maintenance, analytics, operator qualifications, AR, VR, those can be grouped in any of those buckets above, but they can be itself, as a separate entity, but those are integrated with all of the systems above, right? So this is kind of a division of labor to drive the conversation so people understand what goes where, and also how it can help the decision making process. Moving to the specifics on the topic on the digital work instructions today, we are talking about using a module within ThingWorx SCO, Smart Connected Operations, called Operator Advisor. This solution can enable the ability to access work orders from your MES or ERP systems, and how it accesses the work orders, processes the information, extract the right information from the PLM system, and like work instructions. And remember, these work instructions are connected to other product development data artifacts like CAD models or engineering change orders or some other information which are very, very relevant. So the right information gets captured, connected, and the experience specific information gets delivered to the shop floor operator during the operations. Now, with respect to the foundational elements, what we'll be talking and also doing the demo can definitely build other capabilities down the road with additional use cases for quality or operator training or the asset maintenance side of the things. So the operator advisor module is all about delivering the right mashup, right experienced screens for the operator to perform those tasks based on the job orders he's receiving. So the typical steps involved in this, I'm going to walk through those things. This operator advisor module receives the work order information from the downstream manufacturing system. It could be an ERP, it could be some other system. Based on the work order it is receiving, what it's processed or what is about to be get processed in the shop floor, it extracts the work instructions from PLM. These work instructions are again, as I said, connected to other product development information. So it's a closed loop data in the PLM side. And the next step, operator advisor orchestrates the delivery of the information set to the operator in the shop floor. And the same solution set can have other linkages and integrations with assets within that assembly line, other data sources within that assembly line. So we can enhance the overall solution experience to the operator and also the operational management side of the teams. And the last step here is this operator advisor module can collect a lot of data while the operator is performing his job in terms of how much time has been taken for each of those sequence activities, how much torque has been applied, for example, within a specific torquing equipment, and many other elements of the operational side of the things. So that's another advantage from an operator advisor solution standpoint. And moving to the other capabilities, again, this operator advisor can definitely make use of the information data sets coming from multiple source systems. It can interact with other PLM systems as well. It can bring up the 2D, 3D information to the operator. In a way, it can be delivered with the right user experience. And the last but least, it can also help the engineering labs for a similar set of use cases who are responsible for product validations and verifications, right? Similar approach, but the solution is delivered to an engineering lab or a product development lab versus a manufacturing shop floor. Now, the last point I have here before I turn it over to Swapnil is the solution can be delivered with standard monitors, handheld devices like tablets or smart TVs. There is also an element few customers are looking at delivering this with the augmented reality solution set. So there is a lot of activities are happening in that side. With due respect, I will turn it over to Swapnil to talk a little bit more about the use cases and do a quick demo of the solution. Swapnil?
Sure. Thanks, Bala. I'll need this slide. Yeah, thank you. So let me put a context before I turn on the system. So real quick, what is going to happen here is in this demonstration, I'm going to start with an overloaded engineering bill of material for a ski mobile, a snowmobile assembly. Then I'm going to narrow it down to the Ski Pro steering base assembly for this demonstration. And we're going to see how a Pro steering base assembly gets assembled, how the process planners are created from the MBOM, and then how work instructions are generated from the process plan eventually. Now the question is, how do we see it in the shop floor? How the manufacturing people get involved with these instructions? For that, we're going to move on to the operator advisor, and we'll see how to create a work order based on the information that we have from the work instructions that were created in Venture. So your PLM system and operator advisor gets connected here. Then how we will go through each and every steps within the assembling process. And then, of course, whatever the feedback is received from the operator on the assembly line gets recorded. And then this information is then analyzed and for the process improvements moving further. So yes, we're going to get into the system, and I would like to have the presenter rights, Bala.
Yeah, definitely, Swapnil. You have it?
Yes, thank you. So let me know if you can see my screen now.
Yes, we can.
Yes.
So as I mentioned, we're going to consider the snowmobile overloaded bill of material. And what you see here is the various options been created. There's a lot of options and variants. For example, you have a chassis system, you have a suspension system options, you have an engine system. It gets highlighted here on the right hand side. You have the body system options, electrical system options, and accessories. So we're going to consider in this demo the suspension system. And within the suspension system, we are going to consider the front suspension, switchback front suspension option. So what you see on the right hand side on the visualization tab is what it is. And within this assembly, we're going to talk about the Pro steering base, which is highlighted again. So we're gonna get into the details of this Ski Pro steering base and see how the work instructions are generated. So let me open the detail page for this. All right, so here is the detail page for the Pro Ski steering base and the components or the parts that are required for this assembly. This is an design view. We will switch to manufacturing view and we will see the difference between the design view and the manufacturing view, because manufacturing view will definitely have all the components that are needed in the design. At the same time, there are additions. Say, for example, you can see some of these phantom assemblies, sub-assemblies being created. For example, for nut and washer, we need to have this phantom assembly for manufacturing process, I'll say, easiness. So yeah, what you see here is the phantom parts that were not part of the design view. Now from this Pro steering base assembly, let's look at the process plan that we have already created for you. So next step is the process plan. I have created two process plan already. I'm going to use the latest one, which is released to production. In the process plan, you will see the components that are needed for this assembly on the shop floor. It also lists down the tools that are needed. So here is the process plan. What you see is the 7 steps, the high-level 7 steps that are required or that have been created for the process plan. Let's consider that step 10. Here you see 2 parts are involved. One is the carbide rod, which is going to place on the plastic base. So plastic base and carbide rod, how we are to place it here is what an operator is going to perform. At the same time, you have the work center information. This is pretty much tagged in your ERP nowadays. Then you have the skills, what skills are needed to perform this operation. You have the tools. The tools is a rubber mallet that is needed for hammering. And then you have the control characteristics. So like which angle and what are the different control characteristics you have to adopt. Similarly, for the step number 2, you have a nut and a washer, the work center, skills, and the different tools that are needed. So here you can see the torque wrench is needed and clamp is needed. And then you have the control characteristics, which also talk about how much torque to be applied when performing this operation. So from here, what happens next is from the process plan, what you do next is you generate the work instructions. So I'm going to generate a work instructions here. This work instructions gives pretty much the similar information in a way that an operator can perform. What you see here is 3D. You see the clear illustrations and the components, the parts that are required, the tools that are required, the control characteristics that are required, and the procedure to perform. So this is for first step. Then you have the second step. Again, the details, the parts, the nuts, the washers, the tools, and the control characteristic details, everything is pretty much mentioned here. Now the question remains, this is in Venture. How do we pass this on to the shop floor guys. For that, we're going to move on to the operator advisor. This is the operator advisor screen that you look here. Say, for example, this is being accessed on a tablet or on a PC in the shop floor, and then manufacturing engineer creates a work order. What would happen in the work order is the manufacturing process that were created in PLM system are listed here. So we're going to select the Pro Steering Assembly, and we're going to consider the latest manufacturing view, and then you can always select the start and the end date when you have to perform this work order. I'm going to name this work order as 1001, and yeah, I'm going to create it. Now, creating will take a couple of minutes here. So again,
while this is bringing up Swapnil, I quickly want to chime in here in terms of if there are already existing work orders in the other systems, the operator advisor can make use of that information to process and extract the right work instructions from PLM. There are a number of ways customers are looking into that, using a bill of material side of the things in both systems, or also the other triggers can be enabled to get the right information to process and deliver the content to the operator.
Right. Yep. Thank you, Bala, for that. So you can see here the work order is created with the number. And what happens now is an operator launches this particular work order. In this work order, now it can be placed on a single monitor. It can be placed on multiple tablets. The information is pretty much available, very handy for an operator. You have all the 7 steps listed here. You can see them. The first step being placing the carbide on the ski base. What we're gonna do is what we're gonna look through is the status is planned. We have 3D and 2D views, and then an operator can start this process. Once I start this as an operator, I start this process, the status becomes running. I go through the process and I perform those tasks here. I do have a 3D stuff to view what happens when I know what are the parts, I know what are the tools, skills, the detailed installation guide if needed, the control characteristics, what angle to be applied. And what you see here is the process time that will get recorded as we move on. And then operator can even put his notes or any obstacles that he faced during performing this operation. Now, for example, an assembly manager comes in and he starts chatting with the person. He can always pause this process. The status become held, and he can have that side discussion with an assembly manager. Once that is done, he can again resume his work, and your status changes to running. All these gets pretty much captured here. You have the timing for how much time it was running, for how many time it was held. All this gets recorded along with the notes from the operator, whatever he has to update. Once he's done with this process, he makes it complete. Now the status becomes the complete. This particular step has been finished. Now let's quickly look into the step 2, where you have to install a carbide. Here, the process are pretty straightforward. You have the nuts and the washers, and you replace nuts and washers in a given way. I'm going to start this process real quick. You have the tools. Here you have the clamps and wrench that are needed. Now look at the control characteristics. As we mentioned here, there are clear instructions that are given here, like, the tolerance limit is between 20 to 40. Say, for example, if I go and put here, say 25, it still says out of tolerance. And I have to make sure the torque is correctly applied here. For example, I can say 60, and it's within the tolerance. And this is how a person can enter this. And there is various way of doing it. I save this information. It gets recorded. I stop this. I see the process time. It shows me it was running for 46 seconds. And yeah, my stuff is done. And I, again, complete my step 2. So the status is completed. Similarly, you have various steps like the toe plastic on the ski. How do you add that? What are the resources needed? What are the parts involved? What are the tools involved? What are the instructions? Pretty much, you can start it. You can process time is recorded. You have the control characteristics for each of them, and this is how you go on completing the entire process here. So this is how the digital work instructions at the shop floor does work, and a person can complete the entire process, record all the timings, record notes, record obstacles, analyze this data for future needs. I think that's all from the demo perspective. Bala, over to you.
Thank you, Swapnil. Can you hear me?
Yeah.
Awesome. I'll bring my presentation deck back. So the next steps definitely is, again, there are multiple use cases. I see customers evaluating. One of the general things we see is for the operator's ability to raise a red flag when he sees variations for typical things he should be expecting to see, what they call in manufacturing as and-on flags. So most of the operator advisor screens can have those things. When he sees any disruptive, outputs there from an and-on standpoint. So moving to the Q&A, definitely our moderator has set of questions received already from the session so far. So we'll go through some of those Q&A aspects real quick. Definitely, you're going to get the deck sent to you all from this session, and we have our contacts included in that for any follow-ups or queries. Suk?
Right. Bala, before that, I know we were talking about one of the use cases very recently where a customer has connected tools like a connected torque. And all that information can even be pretty much collected and recorded in the system automatically from those tools.
Definitely.
All right. Thank you, Bala. Okay, let me go through the questions, what I have here. While the operator is doing the assembly, is it possible to use an AR capability to automatically detect current status of the assembly and display the next steps in work instructions?
Definitely. So the answer is yes. A lot of customers are taking advantage of the latest offerings within the AR capabilities in the industry. And as we all know, there is progress being made on a monthly basis with respect to different devices, being produced or developed with the AR side. But with respect to the embedment within the operator advisor, yes, we see few customers having that plan in their, overall digital manufacturing transformation roadmap. Some people are using it at the right level, but this can be enabled in a way that the right operator with the right amount of training and certification is about to operate that equipment. So there are use cases with AR enabling those kind of things in some highly complex, accurate manufacturing, devices industries or med devices industries. The other side I see for the AR and other things, PTC does have a specific solution to enable that with the ThingWorks offering, Euphoria Studio or ThingWorks Studio, that's what it's called now, that can be integrated. One other thing I quickly point out that with the COVID and the challenges with people being at the right spot at the right time in person, there is a lot of use cases with the remote help, remote monitoring side of the things. So this complements a lot in that aspect. Hope that helps.
All right. Thank you, Bala, for that good explanation. One more question here. Do you have an option to look back at Winchell problem report or so if an operator not able to apply appropriate torque as specified in the work instruction? How do I report this problem?
Okay. So I would say for any experience or the content delivered to that operator within digital work instructions can have specific linkages which would take them to the released PDFs or released other information within Windchill for operators to know more that can be staged or set up. A problem report could be one of those artifacts from the PLM. He can look at, okay, why this was changed in the last 24 hours. He can see the reasoning and all the product development side of the work associated with that change. Moving to the torque problem, the second part of the question. So I would say, as I said, every screen within the operator advisor side can have an iron-down link for him to put his notes or inputs to raise a red flag when he sees that, yes, this is what the torque was specified, but I see a difference in terms of how my equipment is behaving or the output or the overall, test results or whatever. So that can be enabled within the operator advisor.
Well said, Bob. Another question here is, how do I ensure the correct version of work instruction is released onto the shop floor, since the assembly at shop floor might be lagging somewhat behind in the released assembly status in Windchill?
Okay. So I would say from a process DNA standpoint, this has to be verified from the front end to the back end. So as the product development teams or other teams within the organization makes changes to the parts, whether it is a revision change or a new part getting released or introduced, replacing the old one, whatever that change might be, that change should drive the relevant updates to the work instructions or other downstream artifacts used in the other areas. Now, if so, that verification within the process can be enabled because PLM does manage the overall change process. At the same time, there could be a second level validation or verification from a technology standpoint within ThingWorks Operator Advisor to verify that yes, this screen is making use of the work instructions, which is tied to all the latest released information in the PLM. If there is some other thing which is released but not enabled within the digital work instructions, that can be flagged and notified to the manufacturing engineer or the shop floor supervisor. That can be enabled as well.
All right, good. One more last question here. It's probably not right away relevant to the question and answer, but do you offer on-site development of training records for our manufacturing process?
We do. That's part of our overall service offerings, and we can follow up with the gentleman who asked that question. So yes, we do offer those capabilities as well, and most companies are doing that that digital thread enablement where they have the relevant information stored and managed in one place, and any remote people can create and follow the guidelines to create those work instructions and training documents as needed.
Awesome. Thank you. We can get connected with that person later on. I don't see any more questions here, Bala. If anybody has any other questions out of this, please reach out to me. My email address is on there, and I'll send this a presentation out pretty soon. Please also note that we have our next month WebEx running 26th of August, connected validation and verification within the PLM. It would be a very much interesting topic if you see. I hope this session was also informative and exciting. If you are inquisitive to understand or learn more on any of the topics we discussed today, please get connected. That's all from me, Bala.
Yeah, well, thank you.
Thank you very much, everyone, and you all have a great evening or great afternoon. And we'll hope to see you in our next webinar. Thank you very much.
Thank you, everybody.
Thank you.
Thank you.